Okay, today we're going to learn how to use the equation of a line given in any form, well mostly standard, to solve and graph the line. So the title is Graphing a Line from Equation. Please put the date. Now there are three forms. I should probably put the S there. There are three forms for equation of a line. The first one is standard form, where it's simply in the form of x and y on one side and your number on the other side. There are a lot more rules involved, but we're going to do a separate lesson on that alone, because standard form doesn't really tell us anything. It's just a really pretty way of putting the equation of a line in. So we don't use it that often, but we give it to you guys so that you can translate it to one of these two forms. So the next type of equation of a line is called point slope. And the formula for that is y minus y1 equals m times the quantity of x minus x1, where our x1 and our y1 is a point that's given on the line. So we'll give you the point, and then as always, m is our slope. So that's a great way to put, when you're given just a slope or you're given just a point, to find the equation of a line. Sometimes you aren't always given the y-intercept, so why would you do that? But the one we use most often, the one that's easiest to graph, and we tell you guys to graph from, is called slope-intercept, and that's y equals mx plus b, where m is our slope and b is our y-intercept. It's the point on the graph where it crosses the y-axis. So today I'm going to give you a bunch of equations. We're going to solve them into the slope-intercept form, which means we're going to solve for y. We're going to determine our slope, we're going to determine our y-intercept, and we're going to graph them. Okay? So I'm going to erase the board, pause if you need to finish writing all of this down, and then we will start solving for y. Okay, point number 2. We want to, what's the proper word? Manipulate. We want to change any linear equation, which is an equation of a line. That's what linear means. A linear equation into slope-intercept form. And let's get a different marker. So that equation, as we've written numerous times, hopefully by now, is y equals mx plus b. So for example, if I were to say, here, I want you to graph this line, the line of 3x minus y equals negative 1. Now this is technically in standard form. Well, what we want to do is we want to solve for y. So what's bothering the y right now? Well, this 3x. And remember, we always do the opposite. So since I have a positive 3x, I'm going to subtract. So I get negative y, because that negative has to come down. And because I want to keep it in mx plus b form, I'm going to write this x first. I'm always going to have my x come before that number. Does that make sense? Oh, there's a good black marker. But the y is still not by itself. It's still not isolated. It's still not solved. It has a negative. So that means that I need to divide each term. So I'm going to literally show that I'm dividing every term by negative 1. So now my equation is y equals 3 over 1x, and a negative divided by negative is positive 1. So we've completed our first step. We've solved for y. Our second step is we want to identify our slope and our y-intercept. Well, knowing that we have this equation of a line of y equals mx plus b, we know that our slope, and we always want to put slope in fraction form, is 3 over 1, and our y-intercept is positive 1. So now that we have our slope and our y-intercept, we can now easily graph. And we learned how to graph the line in our previous lesson in video number 4. So I'm not going to go over too much details. But when we graph an equation of a line using slope-intercept, we always start with our y-intercept first. So I'm going to go to positive 1 on my y-axis. And because I have a positive slope, I'm going to go up. And I always go to the right for my run. Because remember, this is rise over run. So I'm going to go up 3. So 1, 2, 3. So this is point 4. This is 1. And then I'm going to go to the right 1. So here's my new point. We usually want to have 3 points before we actually draw the line. So I have 1 point, 2 points. So I'm going to go up 3 again. 1, 2, 3. That should be number 7 on your graph. Over 1. So 7, 2. Now we have a line, so we'll connect the dots. That was a bad connection on my part, I apologize. We draw arrows because the line goes on forever, and we label the line with our equation, which, lucky for me, I did not keep. But because of my slope, I can tell you that it's 3 over 1x plus 1. Okay, any questions? Write them down. We're going to move on to the next example. I'm only going to graph one more of these. So if graphing's an issue, really pay attention. I'm more concerned about you solving for the equation, solving for y to determine that slope. All right, what if you were given, let's see, what's a good one? What if you were given negative x plus 3y equals 6? So our first step is we want to solve for y. Well, what's bothering the y, you work from the outside in. I'm going to do the opposite because I have a negative x. I'm going to add x to both sides. I get 3y, and because I want it in mx plus b form, I'm going to get 1x, because that's what I really am adding, 1x plus 6. And then since now it's bothering the y is a 3, what's happening between the 2 is multiplication. So I do the exact opposite. So I divide by 3, and I'm going to divide each term by 3. No big bars. I want you to show that you're dividing each term by 3. My 3's cancel. So I get y equals 1/3 x. That's why I put the 1 there. And then 6 divided by 3 is 2. So now we've solved for y, which means we can identify our m and our b because we put it into y equals mx plus b form, our slope-intercept form. So we have an m of positive 1/3 and an intercept of 2. So now we can graph that line. Now remember, when you draw your axes, always label your x and your y, and you at least have to have 2 arrows. So I'm going to go along my y-axis, find 2 on it, which is right here. Because my slope is positive, I'm going to go up 1, and I always go to the right. So I go up 1 to point 3, and then I'm going to go over 3. 1, 2, 3. And because I want to have 3 dots, I'm going to do it again. Up 1, over 3. So let's connect our dots. We indeed have a positive slope because as I go from left to right, it's going up. I put my arrows and I label my line with the equation, which is 1/3 x plus 2. Again, questions, write them down. Okay, for the next two examples, I trust now that you can graph them. So we're just going to solve for y and identify our slope